So we're putting it all together today. And things to remember, stretches, reflections, and translations. My husband had a car that was called an SRT. Don't know what it's good for, but same order. So if you think about a car, it's some fast car. But when you told me it was an SRT, I said, wow, that's how you perform transformations in math. And he just rolled his eyes at me. So,
you're not a math guy?
No. He's an English social and sports guy.
Oh. Great, because you guys are both teachers, right?
Yes, he was principal. He was assistant principal here. Oh, a number of years ago, and then he was principal, and then now he works with the diagnostic program at UC.
Oh, cool.
And that's okay. Listen, please. So, here's some forms of a transformed function. So the form, the transformation form, if you take a look at this, this has a whole bunch of brackets. So everything's been factored. So that coefficient of y has been factored out. Because remember, you do your stretches. So you replace y with, in this case, 1 over ay, or y over a, if you want to do it like that. But then if you do a vertical translation, you replace just y. So that's why there's brackets. In terms of x, you do the stretches first, and then we replace x with x minus a for translation. So that is transformation form. It's not y equals, right? Anything to do with y is on the left. Simplified form is solving for y, and then so you have to multiply through by a, bring the k over, and then no brackets inside there, right? So the only brackets you have are because of function notation. Okay, so that's often we'll say, instead of saying simplified, we'll just say solve for y, or express as y equals. Okay, and then the textbook will also might prompt you for these two forms. And again, we could put it on a test like this, or a diploma exam, show it in this form. This doesn't have a name. So all that's saying here is you're just showing the translation, vertical translation by itself, but that vertical stretch has already been moved over. Right? So this is vertically stretched by A. And then leaving these in brackets. Okay, so just be aware of that. Notice just the difference between this one and this one. This still has brackets. Okay. All right, so you can refer back to that if you need to. But we're going to get practicing here all the describing of combinations of transformations. So, it says describe the transformations used to show how each of the following equations can be obtained from your original, y equals f of x. Also show the mapping for the transformations. So there is a decent amount of space, so practice using your words. So this doesn't matter what form it is, you have to look at your transformations. So y is by itself. Look, guys, look for stretches. So a number in front of f, it's -1. Well, that negative is a reflection. So I'm going to hold off on saying any stretch for a vertical. Here, the coefficient of x is 1/2. That's in brackets. So that's a horizontal stretch. So horizontally, or this horizontal stretch about the y-axis by a factor of, so is it going to be a 1/2 or 2? 2. Flip it, right? Okay. No vertical stretch. We already determined that. Now reflections. So reflection, if you see a negative in front of anywhere really, in front of a variable or the f, you know there's a reflection. And so in this case, we're changing the sign of y, because it could have was over there. So if you change the sign of y, it's going to flip it over the x-axis. So reflection in the x-axis. Okay. And then there's only one adding, it's with the x. So this is a horizontal translation. Okay, is that left one or right one? Or left one. Okay. Now, in terms of mapping, you can go right to the mapping form if you wanted to sort of follow the steps. I wrote kind of big here, but your original is xy. If you're doing a horizontal stretch about the y-axis by a factor of 2, then that would be 2xy. Right, so you go from there to there. Reflection in the x-axis changes the sign of y. And then translating left 1 unit, whatever you had here for your x component, now you're going left 1 unit, so you're subtracting 1. So that's your mapping notation. Again, you don't have to show the steps. We're not going to ask for work for that. Okay. Next one is in transformation form. Yeah, you could solve for y, but really, why take the time to do that? Maybe you'll make a mistake when you do it. So here, you'll notice for stretches, there's a 2 in front of the bracket with y. If you look over at x, it's a negative out front, which means negative 1, so there's no horizontal stretch, but there's a vertical stretch. So that's what I want first. So vertical stretch about the x-axis by a factor of, so that's a 2 in front, that's in transformation form, so you flip it, it'd be 1/2. If you did actually solve for y, you would divide this by 2, and so you would have a half as the coefficient of f. That is the stretch. Makes sense? There's a negative here, so that's a reflection in v. So you're changing the sign of x, so that reflects in the y-axis. Then there's 2 translations. Doesn't matter what order you state the translations, okay, because they're separate. They're not going to affect each other. So then vertical, we'll just do vertical translation. So here we're replacing y with y minus 7. So you're only going up 7 units. And then this is a horizontal translation. Replacing x with x minus 3. So you have to go right 3 units. And then for mapping notation, so we're starting with the general point xy. Okay? And then vertical stretch by half would be 1/2 y, or y over 2. Reflection in the y-axis changes the sign of x. Translation up. And then right. So you take a look at C, start to look for some of those, and solve for y, so it's not in transformation form. be called simplified form. Right? Solve for y, and there's no second set of brackets inside the f. Okay, so looking here, coefficient of f is -5. We're going to leave the negative, that's a reflection. So the 5, because it's outside, so in front of the f, that means it's a vertical stretch by a factor of 5. If it was over here, it would be 1/5 y. Okay, so this is vertical stretch by 5. This, any coefficient of x, is a horizontal stretch. Okay, now, normally, in transformation form, we need to have brackets around that x. Okay, the order really doesn't matter for the stretch, it matters for the translation. So before I start writing this out, I'm actually going to factor inside the brackets here. So factor out of 4. Okay. Now I can see what the correct horizontal translation is. So, doesn't matter if I do vertical stretches or horizontal stretches first. They're both stretches, they don't affect each other. So, if I start with vertical stretch. So you can put, I put about there, I'll put 5 as factor. 5, about, or in the x-axis. Doesn't matter how you can rearrange that, right? And horizontal. Horizontal stretch by a factor of, remember for horizontal, there's no way around it. It's always the reciprocal. Okay, then reflection. So if that negative is with the coefficient of f, it's changing the sign of y, which is a reflection in the x-axis. And then again, doesn't matter which translation you do. So vertical translation. Okay, so that's from this number, because if you brought that over, that would be y plus 3. So this is separate here. That's y minus 3. Or sorry, that's something with f minus 3. So that means the original has gone down 3. And then horizontal translation. And that's going to be right 2 units. So, you can go right to your, you want to go right to your mapping notation, you can. What you might want to do, okay, let's think about the horizontal translation. So that would be this and this, because this is reflecting in the x-axis. That's changing the y. So here, horizontally stretching by 1/4, and then right 2. You can go straight to that mapping form. Then for vertical, would be these 3, in that order. So vertical stretch by a factor of 5 would be 5y. Reflection in the x-axis would be -5y, and then down 3. Okay. You don't have to show step by step if you're asked for mapping notation. Yep.
the negative sign was in the brackets with the 4, like say there was negative 4, then it would be a reflection on the y-axis.
Yes.
Okay.
Any other questions? Okay. All right, so let's take a look at a graph to see if we can distinguish what transformations have occurred. Okay, so in question 2 it says describe the transformations in the correct order that take you from F to H. So we've done this before with the separate types of transformations, reflections, translations, stretches, but now putting it all together. So what I recommend you do, look at your original graph, which is the F, and take a look at how wide it is. Okay, if you were to state the domain here, it would be 6 units wide. Then do the same for the range of it. How high would it be? 4. That's going to help us decide whether this thing stretches. Now we're going to look at the image. How wide is it? 2. How high or tall is it? 4. Okay? Well, the height did not change. So that means there's no vertical stretch. Okay? That's what changes the shape. It stretches. And the height has not changed. Okay?
Since it's a quadratic. Oh wait, well, no, it's not a quadratic.
Not quite.
Wouldn't, oh no, it wouldn't, because those are points.
Yeah, we're going to have to be careful of the open circle.
If it was a quadratic, then horizontal stretches and vertical stretches are kind of.
They can, you can find either one. Yeah,
Oh yeah, that's not very clear in our notes.
the open circle.
Yeah, no.
Yeah, it's a little bit hard to see. Just take a look, it's a little bit clearer here. Make sure you see that that's an open circle on the right-hand side of F, and the open circle is on the left-hand side of H. Okay. In any case, take a look. The original width was 6 units, now it's 2. It's been squished, right? So that means it's been horizontally stretched by 1/3. So this 6 multiplied by 1/3 gives you 2. Okay, so I know that for sure. So horizontal stretch by a factor of 1/3 about the y-axis. Okay. Now to get we also know there's a reflection, right? The original is opening down, and the new one's opening up. So for sure there's going to be a reflection in the x-axis. But then what happens? Will it end up where we need it to be? We might have to translate it. So at this point, I would then do those 2 transformations and see what your graph looks like. So here, start with the original. Horizontal stretch by 1/3. Well, that y value there is 0. Sorry, the x value there is 0. Okay, 0 times 1/3 stays. Yeah? It might be. Yeah. It might be. We'll just check it. You have to, we're just going to do this first and then see what we end up getting. Okay? There's also translations, so we'll see. So, I just, how do you do that there? So, stretch this by a factor of 1/3 horizontally, doesn't change it. Then I'm going to reflect in the x-axis. So that's going to go down here. Vertex, that x value is 3. Okay, multiplied by 1/3 is 1. Reflect that in the x-axis is -5. This point here is an open circle. So that times 1/3, 6 times 1/3 is 2. Y value of 1 needs to be reflected, so this is going to be an open circle. So that's my intermediate. It's not. Sorry. I made a view. That's not good.
weird and absolute value solution.
Yeah, it's more rounded, so. So that's my intermediate. That's after those two transformations. Does it look like this one? Well, same shape, but notice how this open circle is on the left and this is on the right. So we're going to have to reflect that also in the y-axis. Okay, so reflection in the y-axis. Okay, how about I do that in blue? So this is on the y-axis, so that stays. This has an x value of 1. Sorry, yeah, x value of 1, so that becomes negative 1. X value of 2 becomes negative 2. So now my graph looks like that, approximately. Okay, and now I'm pretty close. I just have to go 2 left, and so 2 left, and 1 there. Okay, so it doesn't matter which order you put those in. So vertical translation, down 1, horizontal translation, left. Okay. So you want, first thing you always want to do, because from now on, basically, you could have any transformations. So you're going to want to see how wide it is to start, guys. How wide it is at the end. How high it is to start, how high it is at the end. That gets your stretches. If it opens up in one and down in the other, you know you've got to reflect it in the x-axis. Okay? In this case, if we didn't have that open circle, we wouldn't have needed to do a reflection in the y-axis because it's a symmetrical graph to start with. We would just translate differently from what we had to here. Okay? All right, so next one, another type of question. That transformed graph is written, if that transformed graph is written in this form. Okay, so take a look, be careful at the form. Yeah?
If the graph has stolen points appear, could you either do a reflection or just have more of the horizontal translation with both of you, right?
Yeah.
Okay.
Yeah, you could have still done this, right? Or you could have just done translation. Okay, so here, take a look at what form. This is going to be important. Remember, being good at math sometimes is just good attention to detail. So looking at this, we're asking you to state the values of A and B. So from this form, you want to express it in this form. What does that mean then? Notice how this is y by itself, and it's factored in the f. So here, to get y by itself, you don't expand it out. I wouldn't. Okay? I would divide by 2. The reason why I wouldn't expand out is then you're going to have to divide by 2, and sometimes you'll forget that constant term. You might not, but so what I would do here is actually divide both sides by 2, and when I do that, I get y minus 7 equals, and instead of showing it like this, I want to show it with a coefficient of f. I want it to be exactly that same form. So that's going to be 1/2 f negative x minus 3. Okay, and then to get y by itself, you add 7 to both sides. Not 10, I was going to solve the equations this week. That's all it is, same process as any type of equation. Okay, so is this in the correct form? there's your A value. Your B value is here, right? That means -1, so you don't just put negative. That's understood to be a 1. And then that's your H value. So in this case, you're just asked for A. Oh no, you're asked for all of them. So here, A is 1/2. B is -1. H is 3. So again, good attention to detail. That's X minus a number. Is this X minus a number? Yeah, so that number, that digit is 3. If this had been a plus there, and you ended up with this, then your answer would be, for H, would be -3. Notice the sign. You've got to compensate for them. That's a common mistake students make. And it's really important on the diploma exam, because they do that kind of thing a lot. What's A, B, C, what's A, H, A, that kind of thing. So then the constant term out here is K, and that is 7. Okay. All right, so we're going to get into some graphing. We're not doing all of this. You'll notice this is sort of 2 pages both sides. In terms of this, we're going to get up to part C, the writing equations. I'm going to pick and choose a little bit maybe in the graphing part. So, this is where if your original graph has some straight lines, you want a straight edge. So you can get out either a ruler, a battery pack, or your calculator, something straight, a piece of paper, fold it over. Okay, to save a little bit of time, I'm going to use abbreviations for our transformations. Okay, when we're writing them up. I've done some proper ones up until all in part A there. All those words, that's what you have to do on a test. Okay? If you put HS on a diploma exam, they're not going to like that. They know that HS is not a formal definition of something. Okay? So you use words. In this case, we're going to use abbreviations just to help us save a little bit of time. So it says describe them. So describe means use those words. Okay? And then draw the transformed graph. Okay, let's put the rulers on. Every time I say 2 pages, I've been teaching so long, and it's always the same. And so you get rulers out, and then I think all that parents have to do is buy their kids rulers for Christmas. Because it keeps them busy. Looking at hitting people with it, bending it. So buy them for 25 cents. There you go. Okay. So here is, notice how this is not y equals, it's g of x. So that means we've named our image function g of x. Okay? What is it going to look like? Well, we have to think about the transformation. So this is a vertical stretch by 2. Okay, so again, we're just abbreviating. Coefficient of x. So we don't take the reciprocal because it's already solved over there. There's a negative, so that's a reflection. Changing the sign of x is in the y-axis. Because this is solved for g, this constant term tells you the reflection, the translation. Vertical translation of 1. Okay. So, I do not do 3 separate graphs. It will get really messy if you do that. Do each important point, do all the transformations. So, starting on the left here, vertical stretch by 2 means you take the original y value and you multiply by 2. That gets you 4. Reflect in the y-axis, takes that x value of -6, makes it +6. Okay, and then up 1. Then I go to my next important point, and I'll join them up as I go, so I don't lose track. So this next important point has a y value of -4. So when I stretch by 2, that's going to be -8. I'm going to reflect in the y-axis, so that x value becomes +2, and then up 1. And then I'm going to join that up right away. Then the next point, it's going to be horizontal to that, but you want to check it out. So vertically stretched by 2 will be -8. Reflecting the y-axis will be -2 for x, and up 1. So because there's no horizontal stretch, you know that that horizontal part's still going to be 4 units, right? Then this point here, what's the y value? It's -2. Multiplied by 2 is -4. Reflecting the y-axis, so that +4 becomes -4 for x, and up 1. Kind of like a big difference. So when you think about it, if there's a vertical stretch by 2, it should be higher. Well, I look here. This range is 2, 4, 6 units. This new one is 7 plus 5 is 12 units. Twice as much. Okay? And the arm of it, the biggest arm, was going up and to the left. If I reflect on the y-axis, it's got to go up and to the right. Okay, go over to the next one. You can start on it. Okay, and again, you can solve for y, but you don't need to. Okay, this coefficient of y is -2/3. So in terms of y, there's a vertical stretch. Now, because we've replaced y with 2/3 y, we have to take the reciprocal of that. Negative is a reflection. And that is changing the sign of y, so in the x-axis. If you want to solve for y, you're welcome to do that. You can use that, so then you can see that, right? And then a horizontal translation, right? Okay, and then start with important points. I go in order and I join them up in order so I make sure I'm not joining the wrong points up. So this first point here, leftmost, I look at the y value, it's -2, and I'm stretching by 3/2. So that means I'm multiplying -2 by 3/2. Oh my gosh, there's fractions. Can you do it? Yes, you get -3. Okay. 3/2 times -2 is -3.
Yeah.
Okay. Then we're going to reflect in the x-axis, so that -3 becomes +3. And then we're going to go to the right 3 units. What?
also theoretically, like, I mean, this would probably take more time, but if it was like a really complex equation, like it's like uses a bunch of stuff, and let's say it was curves and then wanted to kind of like exact points, could you separate it into like piecewise notation for every section and then return a function and then that way? And then transform each function individually? Yeah.
Okay, so that is the image of this point. Now the next important, you can do in between, but you don't need to. It's going to be straight line. When you're doing a transformation, all of these, if you start with a straight line, it's still going to be a straight line. Okay? So this point here, okay, what's the y value? It's 4. So now we're going 3 over 2 times 4. Let's see if we get this one right.
6.
6, yeah, 6 to start, and then you reflect it. Exactly. So this point, x value stays the same. Now it's going to be at 6. Then we're going to reflect in the x-axis, so now that's going to be at negative 6. Then we go to the right 3, and then we join that up. Okay. This was my first point, this is my second. So now when I get my third, I'm going to join it to this one, not that one, right? So now this point here, y value is negative 4. Multiplied by 3 over 2 give you negative 6. Reflect in the x-axis will be positive 6. And then to the right 3. Okay. And this will be horizontal as well. So this point here, same y value, negative 4, multiplied by 3 over 2 is negative 6. Reflect is positive 6, to the right 3. Because there's no horizontal stretch, it's still going to be just 2 units wide. So that upside down V part is now right side up because you reflected it in the x-axis. Okay? Think about, does it make sense what you got? Okay. Turn over to the next side. Okay? Yep. Yep. So in C, be really careful about knowing your transformations before you start graphing, because there's a coefficient of x, okay, and it's not, and there's also a constant term. It hasn't been factored. Also on the left side, that's minus negative bx minus 3. So there's no brackets. Right? If there's a constant term with the x or with the y, then it's got to be brackets, unless if there's a coefficient, right? So here, this is just saying that our new graph is called P of x. If you want to just call it y, you can. So here, I need to factor out a negative. Here, I need to factor out a half. Okay, is that going to be, in the brackets there, x plus 1 or x plus 4? X plus 4. Remember your factoring. Factoring is really dividing 2 by half. When you divide by half, it's like multiplying by 2, so that's 4. You can always check, expand it back, you get that. Okay, but a common mistake is people put 1. Because they think they're multiplying the half by 2. Now it's in transformation form. I'm not going to bother solving for y. Don't need to. Okay. Vertical stretch, there isn't one. That's just a negative 1, right? Horizontal stretch, there is. by the reciprocal of a half, which is 2. Then reflection, there's just one negative, it's with y, so you're changing the sign of y, so that's over the x-axis. And then translations, again, doesn't matter which order. If I do horizontal translation, that would be left 4, vertical translation, down 3. Okay. Again, we go through all of these transformations with each point. There's 3 points, important points on this graph. So start with the leftmost point, horizontal stretch by 2. So we care about the x value. So the x is -2 there, stretch by 2 is -4. Reflect in the x-axis then, so the y value there is -2, so that's going to be at +2. Then 4 left and 3 down. Okay. Next important point. X value is 2, stretched by 2 is 4. Reflection in the x-axis, well the y value there is 2, so now that's going to be -2. Then we're going to go left 4 and down 3. And then last point here, y value is 4, stretched by 2 is 8, reflecting the x-axis, that's +1 for y, so now that's -1. To the left 4, and down 3. Again, check it out. Here, from -8 to +4, that's 12 units. To start, it was from -2 to 4, it was 6. Okay, so that makes sense. Horizontally stretched by 2. This vertically was 4, and this vertically is still 4. No vertical stretch, so that makes sense. It was opening down to start, now it's opening up because it's a reflection on the x-axis. So that makes sense. Okay, so actually, we've done, so we're going to pick and choose through question 5 a little bit. Let's see, yeah, we'll go to, so if I didn't label this, so if you wanted to label this, this is y equals p of x, okay? So we still use y equals, the name of it is p of x, your graphing. Okay? So, I'm going to leave the first couple, and I'm going to do some of those, let's go to x. Okay, sometimes students don't like fractions very much.
Something's like that.
Okay, so it says the graph of f of x is given, sketch the graph of the transformation. You do not have to write down what transformations occur, but it might help you, just in short form. So here it's solve for y, nothing, that's a -1, so there's no vertical stretch, but there's a horizontal stretch. So horizontal stretch by, and remember, that coefficient is 4/3. So we take the reciprocal, it's 3/4. Right, guys?
Yeah.
How's that ruler? Okay, 5/3. 5/5. That's all you have to do. Like this one. Then reflection, changing the sign of y is in the x-axis. And then this +2 is outside of the f, so that's vertical translation to up. Okay? But it doesn't say to do that, so for example, if that was on a test, and you didn't show that, that's fine. I'm just going to look for your correct graph. So I'm going to start on the left, horizontal by 3/4. So this is -4 for x, times 3/4 is going to be -3 for x. Reflect in the x-axis, so now that y value is -2 becomes +2, and then 2 up. Okay, this point here, now notice this is symmetrical. So that's could be helpful too, right? In any case, this point here, stretching that by 3/4 doesn't change it, because it's on the y-axis. Reflecting the x-axis changes it to here, and then 2 up. This is a fairly straight line here. And then this, you can guess it to be over symmetrical over that way. They're outside or someone's home. 4 here times 3/4 is 3. Reflecting the x-axis, +2 for y, and then 2 up. Okay.
So one question is, didn't the neural start the path not 0 on the y-axis?
Yeah.
Yeah.
No, because this is a horizontal stretch. Right? So it's not changing the, if you're not going 3/4 times 2, and 3/4 times 0. It's a horizontal stretch. Okay.
Weird spider game.
Yeah. Okay, so let's then go to H. So directly below. Okay. Think about that. There's no brackets on the left. So factor. Remember, factoring is fun. Back to math 10. Or rationals.
Actually,
Factor first.
I'd rather factor than have to use the cubic equation. That'd be painful.
Okay. So factor first. Think about rationals. Here, you need to factor out -1. Okay? Yeah, do you have to? Does it tell you to show it in a certain form? No. But I highly recommend it. Because you don't want to get, if you're a little bit stressed on a test or something, you might quickly look at that question and say, oh, I am going, it's -y plus 2, I go down. You go up, right? You got to factor out that negative. So this is a horizontal stretch by reciprocal of 1/2 is 2. Reflection in the x-axis, so that the -y. And then vertical translation up 2. So, horizontal stretch, take a look at the x value. It's -2. Stretched by 2 is -4. Reflect in the x-axis, that y value is now +1, and then up 2. this point here, 2, -6. Well, we start with the x value of 2, stretch it by 2 gives you 4, reflect in the x-axis, so that's going to end up at +6, and then up 2. Okay, so now this is stretched out, right, and reflected. Try to make it curved, because you know it was curved there, not a straight line. It's just going to be stretched out. Okay, here 4 multiplied by 2 is 8. Reflecting the x-axis, +2, up 2. And then again, it's also curved. So, and then continuing in that column, we'll do J. Okay, so we'll do J. So y is by itself. There's a coefficient in front of x, and no brackets, so factor first. Guarantee you basically on a diploma exam that they'll give you something like that and ask you what the horizontal translation is, maybe other things too. And one of the possible answers will be to the right of 6. Okay? But it's not to the right of 6. It's to the right of 3. Vertical stretch by +3. Stretches are always positive. Reflections are stated separately. The vertical stretch by 3, horizontal stretch by 1/2. Okay. And reflection, that negative is in front of F, which means it changed the sign of Y. So in the x-axis. And then vertical translation 3 up, and horizontal translation 3 right. Okay. So lots to do for each of those points. Now, whether you do the horizontal stretch first before the vertical, doesn't matter. In this case, if I do it in this order, y value is -2, vertically stretched by 3 is -6. Horizontally stretched by 1/2. Well, my y value there is -4, so multiplied by 1/2 is -2. Reflecting the x-axis, it's a +6. Then up 3, actually run out of the space, and to the right 3. It's actually a little bit off there. It isn't quite enough space. Yep.
If you're to be given like an equation just in simplified form, let's say in terms of x, would you just never have a horizontal stretch? Because when you factor it out, the bracket will just be.
Right. It depends on what function.
Yeah.
But a polynomial, you could still outside of the vertical stretch.
Yeah.
Right.
With anything else, I think, I don't know. We'll probably get into that.
Yeah, well, sinusoidal you can't. Exponential, you sometimes can. You sometimes can. Depends on what stretch it is.
So these rules apply to all functions, right?
Okay, so there's my first point. This point here vertically stretched by, vertically stretched by 3, 2 times 3 is 6. Horizontal stretch won't change it because it's on the x-axis. Reflecting the x-axis, we'll make that negative 6, then up 3, and to the right 3. Horizontally stretching by half is going to make it skinnier, and then you're also vertically stretching, right? So it's kind of a double win. This one here, this is symmetrical about the y-axis here, so likely you don't even need to do the stretch. You can end up wrapping it symmetrical about the line x equals 3. But let's do it just for practice. So a vertical stretch by 3 would be at negative 6. Horizontal stretch by half would be at 2 for us. Reflecting the x-axis would be at positive 6. 3 up, and to the right 3. Okay. So, okay, I'm going to go back and finish these graphs in question 5 that I didn't do to start. So I'll go back to 5A. Looking at this, again, I just write out briefly. So this will be a reflection in the y-axis because we're changing the sign of x, and a vertical translation 4 down. So take the first point, reflection in the y-axis, negative 4 becomes positive 4, and then translate 4 down. This next point here, the x value is negative 2, reflect in the y-axis, it's positive 2, and then 4 down. And join as I go. Next point here, reflect in the y-axis stays the same, and then 4 down from that. Point up. This point, reflect in the y-axis becomes negative 2, 6, and then 4 down. And then the last point, reflect in the y-axis, that's positive 3, becomes negative 3, and then 4 down. Okay. So you can see the sort of the long arm to start is now at the end because it's been reflected in the y-axis. Next one is in transformation form. F of x over 2 is the same as 1/2 x, if you like to think about it that way. So in this case, and we're calling this one is just now using g of x. You can replace that with a y if you want. G of x is just going to be the name of your transformed graph. So in this case, there's a horizontal stretch by 2, reciprocal of a half. Then a reflection in, well, if you're changing the sign of y, that's in the x-axis. So first point, stretch by a factor of 2. Well, the x value is negative 2, by 2 is negative 4. Reflect in the x-axis, reflects up to positive 2 there. This point here, horizontal stretch by 2. Well, x is 2, times 2 is 4. And then reflect in the x-axis, positive 2 for y becomes negative 2. It's a little too long for me to make it nice, straight. There. And then the last point, stretch by 2 would be give me an x value of 8. And then reflect in the x-axis would be y value of negative 1. Okay. Again, it's kind of opening down to start. Because we were reflecting in the x-axis, it's going to open it up. So at least, you know, do a little mental check. Does it make sense? that image graph. Okay, next one. This is in transformation form. So this is a vertical stretch by, now y has been replaced with 3 over 2y. So the stretch factor is the reciprocal, 2/3. And then a horizontal translation, x has been replaced with x minus 2, so that is right 2. So when we're stretching by 2/3, it's a number less than 1. So that means it's going to be a compression. Okay, so leftmost point, the y value is -3. So 2/3 times -3. That's going to be -2. Okay, so it goes there, and then to the right 2. This looks like part of a parabola. So it looks symmetrical, so our new graph will be symmetrical as well. This vertex here has a y value of 3, stretched by 2/3 makes it 2. It's kind of an easy one. Oh, sorry, 2, and then to the right 2. So I just to the right 2. Okay, and then I'm going to join as I go, make it curved, because the original was curved. Because we're vertically stretching by 2/3, it's actually vertically compressing it, so it's going to look wider. Because it's like a parabola, I don't know if it's exactly, we'd have to check the equation, but it is symmetrical about that vertex. Then right now, from the vertex that's 3 units, it's going to be 3 units here. Okay, let's test out and see if I'm correct. So this last point, vertically stretch it by 2/3. So -3 times 2/3 is -2. We already did that. Same as the first point. Then to the right 2. Yep. So whether you do it symmetrically or actually transform that each point, works out. Next one is not in transformation form. It's giving a name. So this is like y equals. Giving a name to that transformed graph. And there's 2 stretches. So a vertical stretch by 2, because it's solved for y, that is the vertical stretch. And a horizontal stretch by the reciprocal of 3. Okay, so take your leftmost point. Doesn't matter which order you do the stretches. So if I start with the y, vertical stretch by 2 would give me the y value of 8. My x value is -3 times 1/3 is -1. Pretty easy numbers in this case. This is on, next point is on the y-axis, vertical stretch. So y is -4, vertically stretched by 2 is -8. And then horizontal doesn't change it. So I'm going to graph this because I don't have a steady hand. Okay, always doing them in order so I don't get mixed up what I have to join. It's not symmetrical, so I do need to do this last point. So y value is 2, stretched by 2 is 4, horizontal, so 6 for x, by 1/3 is 2 for x. And then again, join those up. Okay. So horizontally compressing it, right? By multiplying by 1/3, it gets skinnier. And as well, vertically stretching it by a number bigger than 1, it's really skinny. Okay. So E, this has been solved for y. It's already factored, so that's good. So vertical stretch by 1/2 because of that coefficient. Okay. Then inside the F brackets, the -1 has been factored out. So there's no horizontal stretch, but there's a reflection in the y-axis because you're changing the sign of x. And then a translation, x has been replaced with x plus 2, so you're going to left. Okay, so first point, vertical stretch by 1/2, so y is 2, becomes 1. Reflect in the y-axis, the -4 for x becomes +4. And then to left. Okay. Next important point, y values -2, stretched by a half is -1. Okay, so I got a little distracted, so we're going to do that second point again here. So -2 times a half is -1. In the y-axis stays the same, and then to the left 2. Join that up. Next point here, y value is -2, stretched by a half is -1. Reflected in the y-axis will be -2, and to the left 2. Last point here, y is -4, stretched by a half is -2. Reflected in the y-axis is -4, to the left 2. There you go. Okay. You can tell it's, if you look at the original range, it's 6 units high. This one is 3 units high. Okay. Okay, then G, which we didn't do. So again, this is kind of like y plus 3. It's just that our transformed function we're going to call P. So that's in transformation form. All right. There's a vertical stretch by 2. All right, because that's already over there. Oh, actually, this isn't in proper transformation form because of the 2. Right. So really, in proper transformation form, it would be this. Okay. In any case, vertically stretched by 2, reflection. So x is changing sign, so that's in the y-axis. And then a vertical translation, 3 down. Okay, so first point, vertical stretch by 2, that will become 8. Reflected in the y-axis, so -4 becomes +4, and then 3 down. Next point, y value is -2, stretched by 2 is -4. Reflected in the y-axis is +2, and then 3 down from there. You can see it is really stretched out. Okay, then next point, vertical stretch by 2 becomes 4. Reflect in the y-axis stays the same, and then 3 down. Okay, and so what's that going to look like? It's not, you got to make sure you get the shape rounded and be the proper round, not underneath. Okay, so if you think about, this is straight here and then up and to the right. So this is straight from the right and then up and to the left. Okay, last point, y value is 1, stretched by 2 is 2, reflect in the y-axis. So 4 becomes -4, and then 3 down. All right, and again, that's curved like that. And that was G. And then I. This one is not, I want to factor it to make sure I get the transformations correctly. So if there's a coefficient with either y or x, make sure you factor out the coefficient. Now that's actually in transformation form, so that's going to be a vertical stretch by a half. No horizontal stretch. Vertical translation up 5. Horizontal translation for left. Oops, left. Okay, so first point. 4 times a half is 2. Translate up 5 and 4 to the left. There. Next point here, stretched by a half is -2. Then up 5, 5, and to the left 4. Okay, so that joins up with that. Straight line. Last point, stretched by a half is 1. Up 5, that's going to be 6, left 4. Okay. And I think we've caught up now. Okay. So that is the end of parts A and B.